Let's say that we have the differential equation dy dx, or the derivative of y with respect to x, is equal to negative x over y. Let's say we don't know how to find the solutions to this, but we at least want to get a sense of what the solutions might look like. And to do that, what we could do is we could look at a coordinate plane. So let me draw some axes here. So let me draw a relatively straight line. All right, so that's my y-axis, and this is my x-axis. Let me mark this as 1. That's 2, that's -1, -2, 1, 2, -1, and -2. And what I could do is, since this differential equation is just in terms of x's and y's and first derivatives of y with respect to x, I could sample points on the coordinate plane. I could look at the x and y coordinates, substitute them in here, figure out what the slope is going to be, and then I could visualize the slope. If a solution goes to that point, what the slope needs to be there, and I can visualize that with a line segment, a little small line segment that has the same slope as the slope in question. So let's actually do that. So let me set up a little table here. Let me do a little table here to do a bunch of x and y values. Once again, I'm just sampling some points on the coordinate plane to be able to visualize. So x, y, and this is dy dx. So let's say when x is 0 and y is 1, what is the derivative of y with respect to x? It's going to be -0 over 1, so it's just going to be 0. And so at the point 0, 1, if a solution goes through this point, its slope is going to be 0. And so we can visualize that by doing a little horizontal line segment right there. So let's keep going. What about when x is 1 and y is 1? Well then, dy dx, the derivative of y with respect to x, is -1 over 1. So it's going to be -1. So at the point 1, 1, if a solution goes through that point, it would have a slope of -1. And so I draw a little line segment that has a slope of -1. What about when x is, let me do this in a new color. What about when x is 1 and y is 0? Well, then it's -1 over 0. So this is actually undefined. But it's a clue that maybe the slope there, I guess, or if you had a tangent line at that point, maybe it's vertical. So I'll put that as a question mark. Vertical there. And so maybe it's something like that. If you actually did have, I guess it wouldn't be a function, if you had some kind of relation that went through it. But let's not draw that just yet, but let's try some other points. Let's say that let's try the point -1, -1. So now we have -1, which is 1 over -1. Well, you would have a slope of -1 here. So -1, -1, you would have a slope of -1. What about if you had 1, -1? Well, now it's -1 over -1. Your slope is now 1. So 1, -1. If a solution goes through this, its slope would look like that. And we could keep going. We could even do 2, -2. That's going to have a slope of 1 as well. If you did +2, +2, that'd be -2 over 2. You'd have a slope of -1 right over here. And so we could do a bunch of points. Just keep going. I'm now just doing them in my head. I'm not going on the table, but you get a sense of what's going on here. Here, your slope would, if it's -1, 1, it's going to have a slope of 1. So at this point, your slope -1, 1. So -1 is 1 over 1. So you have a slope like that. At -2, 2, same exact idea. It would look like that. And so you get when you keep drawing these line segments over these sampled points in the Cartesian or in the xy plane, you start to get a sense of, well, what would a solution have to do? And you can start to visualize that, hey, maybe a solution would have to do something like this. This would be a solution. So maybe it would have to do something like this. Or if we're looking only at functions and not relations, I'll I'll make it so it's a very clear. So maybe we would have to do something like this. Or if the function started like here, based on what we've seen so far, maybe it would have to do something. Maybe we would have to do something like this. Or if this were a point on the function over here, it would have to do something like this. And once again, I'm doing this based on what the slope field is telling me. So this field that I'm creating, where I'm sampling a bunch of points and I'm visualizing the slope with a line segment, once again, this is called a slope field. So hopefully that gives you kind of the basic idea of what a slope field is. In the next few videos, we'll explore this idea even deeper.